So we're reaching the end of the session today, and actually our last contribution and keynote panel is from the Ceph developers. So let me welcome them on stage for the Ask Me Anything session that is about to start now. Please. So this is expected to be a very interactive session. As Matthew was already saying before, we have a couple of microphones around. So please, let's try to make this as interactive as we could, and everyone is more than welcome to reach the microphones and ask questions to the developers. Josh.
Thank you, Enrico. Yeah, so we want to make this very interactive, as you said, just opening up to questions and answers. I think we had a few interesting areas to explore from the user buff at the end of the day yesterday. Dan, did you want to start with those?
That's on now. Yeah, that's right. We had some leftover questions from the user feedback buff. One of them was to, let's say, OSD developers. What's the current status of like WPQ versus the M-clock OSD scheduling? Someone answer that.
Mic check. Okay. What's the current status? The current status is that M-clock has been the default OSD op-queue for a couple of releases. It's been a bumpy ride. We have gotten a lot of mixed feedback, I have to say. This came through mailing lists. This came through the survey that we were talking about that we did for the user council, because that was one of the questions we intentionally added. What we have realized is that the testing that we did, at least in the, I believe, the Quincy/Reef timeframe from the development side of things, wasn't enough. End of story. So once users started to use it at a larger scale, and in fact, we started to do more of large scale and more. There is a group called Delivery Focus Group at IBM, DFG. They kind of replicate some of the object workloads that large scale RGW users have. They started to kind of push the boundaries in terms of recovery and backfill and scrubbing. We started to find more rough edges. So as we found those, we started to fix those. So things that have improved since we introduced M-clock as the default is particularly the default behavior, because we started off with high client I/O profile as the default, and that clearly didn't work out. So we changed it to balanced. We did a bunch of work to improve the recovery behavior, because one of the things we realized that by default, recovery was taking forever to happen because we were prioritizing client I/O. Third thing that came out was M-clock heavily relies on the characteristics of the device. So there is a benchmark that gets run when the OSD initiates. That, in a lot of cases, wasn't accurate. So we had to add some checks and balances in terms of like thresholds that were insane in case of in some of the environments where it wasn't doing a good job. We still highly encourage users to run their own benchmark and set these initial values. And at least we've gotten feedback that those users who've done that have gotten much better experience with M-clock. So the idea is that M-clock has been introduced with the usability in mind. There are rough edges that we have found and fixed, and we are looking for more and more feedback here. So as we speak, we are continuously improving even the snapshots and scrubbing and like background activity behavior with M-clock. So I would say that is one of those things that we thought was this cool, awesome thing that we've tested and introduced in the wild and it would do wonders. It wasn't as pretty of a picture initially, but we want to work with the community and continue to invest in M-clock. WPQ still exists, but if we have to think about long-term usability in mind and also the journey with client versus client QoS, mClock is the way to go. So I hope that answers the question. And in fact, I think Matan briefly mentioned it. Crimson currently doesn't use mClock at all, but we are adding support for it for the tentacle release.
Thanks, Neha. So I think we've made a mistake here. Maybe we should go one by one, introduce ourselves, so that the audience knows what kind of questions.
I'm done with my introduction, I think.
Excellent introduction.
Passing it on.
So Neha can answer questions about the OSD. So I'm Dan. I can probably answer questions maybe about operating a Ceph cluster or something like that, unbreaking it.
My name is Matan. I'm leading the Crimson project.
I'm Ramana Raja. I work on Ceph's block device component RBD.
Hello, I'm Venky. I'm leading the Ceph team.
Hello, my name is Redouane, and I'm part of Ceph ADM team.
Hi, I'm Zach Dover. I'm the head of docs. If I don't get a chance to tell you this again during this Q&A, I will be at the Big Bang Cafe at one of the tables that is a meter off the ground with a chair in front of it, and you're welcome to come over and talk to me at any time today.
Yep, I'm Travis, lead of the Rook project. So, yep, hoping for Rook questions.
Yeah, my name is Niels, and I work on Ceph CSI, so the Kubernetes integration, basically.
I'm filling in for Radoslav, who's the tech lead of Rados. I happen to know some things about the OSD, so I'm standing here. And also for Sam Just, who unfortunately couldn't make it. And for Igor, who's the Blue Store tech lead. But if we have Blue Store related questions, we also have Adam here in the crowd somewhere.
Hello, I'm Orit. I'm going to answer a question about NVMeOF. I used to be a Redis Gateway developer, so probably some Redis Gateway, but I'm happy if there's other one, people in Redis Gateway that can also answer more detailed questions.
Hey everyone, I'm Yaarit, and I'll take any telemetry questions.
I am Josh, and I'll take any extra questions that other folks would like me to expand on.
Okay, so just a reminder, there's 2 lonely microphones there, and like anyone could stand up and yeah, excellent. Okay, so great. I thought maybe Greg was leaving the room, but he's coming to the mic. Excellent. Let's give the priority to the audience first.
What's the current state of advice on how many OSDs I can scale a cluster to?
Brilliant question. You tell me. Right? Because I'm going to say like 100,000 or whatever. But I mean, real production clusters, I think I heard 5,800 somewhere. I know we've gotten like 6,000, 8,000, and we've done tests with 8,000, 10,000. So far, I think the maximum I've heard is 10,000, but if somebody wants to push the bar, we are up for it.
Does anybody have a larger cluster in the audience?
Exactly. Let's do an auction. So
yeah,
the bidding starts at 5,000. Anybody above 5,000?
Dan, how about
we got 5,000 over here.
Contest.
6,000? Anyone? 6,000, we have it over here. Okay, 6,500, surely. Oh, here we go. Really? No. Hey, you, really? You're going to have to pay.
What if you put a bounty to it? Like, like
6,000,
largest cluster gets a bounty.
6,250. 6,250? Okay, we're with the gentleman in the back. It's 6,000 still. Anyone else, please? 6,000. Okay, stand up. Oh wait. Oh, sorry. We got a last minute phone in. Pardon?
20.
13,000.
13,000.
Oh.
There we go. We should talk afterwards.
13,000 in one cluster. In one cluster. So you increased the Ceph.conf value for max OSDs per cluster then? Yeah, of course. Yeah. Okay, can anyone please beat 13,000? Yeah, we have a winner. So, all right. We can find about it. So, but more reasonably, yeah, a few thousand's probably the limit. But, yeah. So, we have a question here, yeah.
So this is might start with you, Dan, but then maybe there could be some feedback on the developer side. So we often see you talk about using upmap as a way to kind of head towards a goal state without the cluster being unhealthy. So my first question is what are we trying to avoid in not having the cluster unhealthy but otherwise fixing itself? What specific challenges is that trying to avoid? But then maybe is there any work so that instead of having to use something like upmap to avoid that unhealthy part, that the cluster would just deal with that on its own and not have problems caused by that, maybe?
Sure.
Yeah.
That's thank you. I love talking about this topic. I mean, basically it's like in Ceph, there's two ways to run the cluster or to fix the problems. Nothing's perfect, right? So we can either make Ceph better from the bottom up, all the excellent developers make, let's say, backfilling more reliable, more transparent, client I/O, QoS, make it from the bottom up, make it rock solid. Anything that an operator does, make it have zero impact. If you want to upgrade, if you want to reboot things, if you want to all of that, let's make it from a Ceph bottom up thing. But there seems always to be some missing things, right? And that's the kind of top down stuff. It's what we as operators do. If you do it 2 or 3 times, okay, you better write a script that automates that part, right? And that's sort of from that point of view is where just naturally these upmap type of scripts and the PG remapper that DigitalOcean has made, the collection of I don't know, how many different repositories are there out there of useful, wise scripts on GitHub? I know CERN's got a repo. There's, I don't know, does anyone else maintain a repo of helpful Ceph scripts? There's 3 or 4 of them out there that then the wisdom gets shared around. Somehow those features trickle down into the bottom eventually, right? So specifically to answer your question, right? That was a lot of philosophical things. The things that are on the top, okay, we want to make them in the bottom over time. And with this exact upmap remap feature, that's used in the case where you sort of want to, you have a lot of change, you want to implement a lot of change to your cluster. So maybe you have 13,000 OSDs and they just went out of warranty and now you need 15,000 OSDs to replace them all. How do you do that? The real lived experience of Ceph operators is you can't just Ceph ADM add host, Ceph ADM create OSD with another 15,000 OSDs in that cluster. It's something that you have to drive that car. It's going to have a little problem. It's going to stutter here and there. Something might go wrong a little bit. You need more control of that, right? So upmap, remap, PG remapper from DigitalOcean, this was a tool that let you pause things, do things in a gradual way, get more control over where the data is moving. Yeah, so the specific use cases are I don't know, you want to drain 100 servers because you want to replace them, or 10 servers or so. The operator can type one command, run a script, and then go away. And Ceph will gradually, with the parts of Ceph that we know work gradually, it will gradually move the data. Whereas if you were to just do it the normal way, the documented way, it might be a little bit too disruptive. It might get out of control, things like that. That feature, upmap, remapped, and PG remapper, Laura Flores and the Balancer team are working to integrate those features into the Balancer natively now, so that, for example, when you add a lot of capacity to a cluster or remove, you have so many tens, maybe 50% of the data is misplaced, and the progress bar says 6 months or so it's going to take to finish whatever you've done. The Balancer natively will do the necessary to bring that progress bar down to 1 hour or something like that. Yeah. The data will still move eventually. It will still take 6 months or whatever to do the thing. Hopefully nothing takes 6 months, right? But it will just do it in a way that's more stable, more transparent, yeah. Okay.
Hi, good morning. I was wondering, are there any ideas or plans to make Ceph as smart to have it figure out where to store data when you have multiple storage tiers, like HDD, SSD, NVMe? So as an operator that does not know how the future would look like, Ceph will figure out where to store the data instead of, well, you have to do storage steering by yourself, have a lot of in-between logic to make sure you get the data where it should be, but that Ceph actually does it by itself. and just tell you, you should add a little bit more of NVMe, and then you will have a lower latency and things will be better for you. Without advanced planning, without, well, a lot of things that go into it, then you need to make it scale and make it resilient.
Does anyone feel up to answer that?
I think it's a really interesting idea. I think it might be very easiest to implement in terms of the RGW layer with its kind of lifecycle ability to tier between different kinds of storage. I'm not aware of any work going on in that direction right now, but it's certainly a very interesting area for future research, I think.
But instead of like have it workload dependent, push it to the Rados layer. I'm not sure if that would make sense, but then you don't have to think about what workload. You will just leave it up to Rados. Well, Neha would have an opinion about this, I guess.
I have an opinion about it. I find the idea very cool, but I am also bitten by doing some auto stuff a little bit too much. So I guess I think let's maybe noodle around the idea and see how it can be done. Because there are opinionated operators. They'll be like, "Why did Ceph do this?" Right? Like, I didn't want it to do this, and it's just doing something random and using up my space for things that I didn't want it to. So we've got, all the stories about the autoscaler and all the auto-tuning and everything, so which is why we've been a little more conservative on that side and more about like, hey, you really, really want to do this, you can go do this kind of stuff. But it's still an interesting idea that we can probably talk about more.
If I may, maybe I'll rephrase this question in the form of an answer. So number one, at the Rados level, what's the plan to replace the former cache tiering feature, where you could have a pool of SSDs and a pool of disks, and Rados would? And secondly, another place where caching we've attempted a few times. What's the status of persistent caching on, let's say, hypervisors, or let's say block storage clients? If someone has any info on that, that'd be. Because I think those might be potential answers to what you're asking, right, Stefan?
Yeah, so I can speak a little bit to the block storage part. So a few years ago, Intel contributed this persistent write cache for RBD to be able to cache data locally on the client side with ordering in the way that it does the writes and stores them back, sends them back to Ceph. That way, it's a crash consistent viewpoints of the VM image. And so even if you lose that cache, you still have a consistent point of view from the file system and application, hopefully, point of view at a higher level. So this makes it quite a bit better than DM cache in that sense, and for maintaining that crash consistency. There's some new work going on into that to make it perform much better. I think there's some issues with fleshing performance right now. So I think we'll see how that goes over the next release or two. That could be a very good option for high performance with slightly reduced durability requirements in the future.
Yeah, I mean, as far as cache tiering is concerned, there are no plans to bring it back in the classic OSD, but for Crimson, there is, and C-Store. Yeah, so if you want to speak for it.
For C-Store specifically, we do plan to have a attempt to use less performance storage devices to store the call data and so forth, and faster for the metadata and hot path. Still work in progress, but I think we have a decent amount of progress so far. So once C-Store is default, feel free to try it out and see how it works out for you.
Question about manual trim for BlueFS. There is an option in BlueFS tool for run this command, but you cannot do it actually. At least there is an option in doc, but no option in actual tool.
So is there a discrepancy between the documentation and the usage in the tool?
Sorry, which option did you mention? Sorry.
Trim for BlueFS.
Adam, thoughts? It should be there. So it's a bug. Let's just say it's a bug. File a tracker.
Is that okay? Fine. Trimming the blue. Yeah. Yep. Question. Yep.
Good morning. First of all, thank you for being here. My question is about RGW and Keystone integration. We use OpenStack Keystone as an authentication source. And I'm wondering if any work is going on in making like roles more granular, or with multi-tenancy right now it's all on the tenant basis and not on the user basis. So I'm wondering if there's any work going on to make this more refined, if you will.
So actually there was work adding more accounts to RGW. I guess it didn't get to the Keystone integration yet, but that's something you can raise in one of the dailies and we can discuss it.
Well, thank you.
Good morning. Thank you for doing this. I have a Crimson C-Store question. Specifically, so we have been hearing about performance improvements and also efficiency improvements, and I was wondering about specifically about the energy and efficiency impact Crimson and C-Store might have from not only from an environmental perspective, but also from power savings perspective, and it could also help with density and cooling in data centers. Are there any expectations around the impact of this?
The answer is yes. As you already know, Crimson and C-Store specifically is with collaboration with Intel, and they have run some evaluations in terms of more efficient, energy efficient cores to see how we interact with those, and we were able to actually perform better. These results are not out there yet, they're not public, but yes, this is one of our goals, to use energy at the end and CPU utilization more efficiently.
Thank you.
I'm going to be greedy. First of all, I'm really interested to know about all of those repos that you mentioned, Dan, and if there's maybe a way of sharing who's publishing all of those. I'd love to see some of them. But my question is around Crimson C-Store. There's a lot of talk around that HDDs are becoming less and less effective, and we should be using SSDs for cost effectiveness and so forth. And I'm willing to believe it. I'd love to see future procurements being able to afford SSDs if prices come to the right point. But if we're still on HDDs in 3 and 5 years' time, and Crimson is default and production, is Crimson being written for that, or is it purely for Flash?
The main idea is to really make use of modern storage devices to really saturate them. I don't see a reason why we should deprecate usage with hard disk, but and I also don't see a reason why it should impact your current performance. We should maybe even do better, but the idea here is to really be able to make use of what we perhaps because of our current implementation, not really able to really push your NVMEs to the end. So the answer is you can keep your current environment same as it is. We don't expect you to replace, because we will in the future replace our OSD implementation for you to remain the same, maybe better.
Yeah, and I'm aware that I don't know what the plan was with FileStore and BlueStore, but history tells us that FileStore eventually went away when BlueStore came on. Is the intent that BlueStore will continue?
That's a tricky question here, because C-Store is introduced mainly because it's written using, talked about it yesterday, a Crimson native architecture to really have the entire I/O path written in the same architecture and not having to allocate some cores to being run asynchronously and some cores for the multi-threaded with BlueStore. So at first, the first stage is to really be there for Crimson. About classical usage with C-Store, to be honest, I'm not sure here yet. May work well.
To answer your question, it took what, 6-7 years for FileStore to go away after BlueStore became default, and for good reason, right? There were lots of problems with FileStore, and we did a lot of research before deprecating FileStore. So I don't see a reason for us to deprecate BlueStore if people like it. If there are no issues, I don't see for us a reason to say, oh, just this cool new C-Store thing, so let's just remove the old one. So if there are real problems with BlueStore, that's a different point. But at this point, I don't see a reason for us to deprecate BlueStore.
Right, thank you.
Yeah, I mean, currently, the tech preview we did is alienized BlueStore, essentially. So it's Crimson OSD running with BlueStore.
Hi. Are you considering expanding support for Alma, Linux, or Rocky?
Are we considering expanding support for Alma, Linux, or Rocky? I think in general, yes. There has been some question, especially recently, about kind of what sort of distribution we can use as a stable basis for our container images going forward. And I think that's still under discussion and research. And I think Alma and Rocky are definitely some potential options there.
Thank you.
Okay, there were some questions yesterday at the user feedback session about, let's say, Cephfs and what kind of, so it's about Cephfs consistency, but maybe more general, like when something goes wrong with Cephfs, it can be scary. So what kind of work is being done in Cephfs to like reduce that stress level from maybe blocked, stuck ops, or maybe file system inconsistencies, things like that, yeah.
Yeah, so a lot of work has gone recently in, and that's in the main branch to at least reduce the, these kind of warnings that show up and scare folks. As far as talking about the consistency itself, I mean, Cephfs is a POSIX compliant file system, so, and it will always be like consistent first, correctness first over performance. So that's not going to change. But as far as the scary warnings, those are being addressed on priority. Some of them were like just red herrings, so they have been taken care of. But if you still see some of them shooting up, I mean, you should talk to us.
Okay, so let's try to get Ceph ADM and Rook into this discussion somehow. So, I mean, maybe with that question about the tooling, like outside tooling and like the bottom-up stuff, like maybe you have some thoughts about that from the Rook and Ceph ADM perspective, like the roles of those tools in doing these really difficult operating tasks and how that will evolve over time. Yeah.
So what's the question in this case? Is like if I'm working in tooling or to improve the deployment?
So let's say right now it's like Rook, let's say Ceph ADM, because I know it better, is really, really great at getting a cluster installed, really great, adding capacity, draining capacity, upgrading cluster, it's like perfect. But the more complex things, such as, let's say replace half of my hardware in a cluster and push up one button and do it, orchestrate that kind of task. Or orchestrate, I need to upgrade the host operating system on my 500 nodes cluster, things like that. Where do you see, like, is that in the vision for these type of tools, or is this something that should always remain outside the scope of Ceph itself?
Yeah. We have a lot of customers and users asking for possibility to include the operating system deployment as part of the tooling they provide. I think a lot of people were struggling, and it's one of the major pain points. I think as far as we know, it seems like upgrading the operating system is becoming more challenging than upgrading the Ceph itself. Indeed, there is some ongoing work and thoughts in how can we provide some tooling around, like to make it easier to upgrade the operating system as well. But like nothing yet on the roadmap, because we have other priorities at this moment. But definitely this is something that we'll be looking into the future to improve like the whole experience around deploying with Ceph ADM, upgrading the cluster itself, upgrading the operating system, making it easier. So it's in a roadmap, but we don't have like a release for it. Yeah.
Travis, do you?
Yeah, and then for Rook, I mean, Rook's goal is ultimately to automate things for Ceph in the Kubernetes environments. So there are certain responsibilities that are clearly at the Kubernetes level. So if you need to upgrade nodes, upgrade the operating system, that's going to be at the Kubernetes level, and there are lots of tools related to Kubernetes and OpenShift for that purpose. And Rook doesn't have any automation or plans to automate things related to that, since that's outside of Rook's scope. But at the same time, Rook is aware and wants to be aware and plug into those mechanisms to make sure that while you're upgrading your nodes, that we have these pod disruption budgets to make sure that Ceph is still highly available and doesn't have outages while you're doing those upgrades. So for example, you can take down an AZ and upgrade all the nodes in that AZ, and Rook will update dynamically the pod disruption budgets so that, okay, only allow the OSDs in that one AZ to go down while you're upgrading that AZ. Everything else stays online in your cluster. And then you can, as long as you go one AZ at a time, then the upgrade goes smoothly. And so that type of integration, definitely we've had that in there for some time. But the more we can do to automate, if there's any pain points around that, certainly we'd love to hear that feedback and make it as smooth as possible.
Yes, I'm here, like, for everybody in the room. If you have like some specific requirements or questions, just come talk with us, and we will be more than happy to hear from you and try to help and to include requirements and in the next releases. Because I mean, at the end of the day, it's when you talk to the users, you figure out what are the real problems they are facing. Sometimes from development side, it's not easy to get all that feedback. So yeah, we'll be around. If you have any requirements or questions, just come to us.
Okay.
Talk to us. Thank you.
And also add, of course, if there's any Ceph automation that needs to happen, Rook's goal is let's automate that wherever it makes sense. If you need more OSDs deployed or replaced, or that's our goal, to automate it and make it as simple as possible.
Okay, thanks guys. Let's get some questions. Who was first?
A question about Crimson. Are you planning support for DPUs like Bluefield 2, and how far is it?
Support for what?
DPUs.
SmartNICs, NVIDIA, Bluefield.
To be honest, I'm not completely sure about whether we still have dedicated support for that. But that's a good note. You can bring it up in the Slack channel, and we'll be sure to follow up on that.
What do you want? You want to run the OSD on Bluefield?
Yeah.
I think the ARM core is not strong enough for OSDs. Bluefield ARM core is small. They have I don't know, 8 cores, so it's an ARM, very small ARM. I don't think even Crimson will fit in.
With small core count, there is really no reason to do so. Maybe interesting to try, but
it's a slow ARM. It's not. It's the idea on DPUs is actually doing things in S6 really fast path. The ARM is the slow path, and the OSD is very specific, so it needs to be on the slow ARM core.
So there is no advantage?
I think so. At the moment, no. Maybe when we have C-Store, because BlueStore will be too heavy.
Yeah.
When we have C-Store, maybe we need to see how much cores we need for a single NVMe. And it will be for single NVMe.
I think further in the future, there also have been some discussions around ideas that it could be possible with these kinds of offloads and potentially using those for things like replication between OSDs, but that's a kind of cloud in the sky sort of idea right now.
Thank you.
Yeah, we're looking, for example, to put the NVMe OF gateway with SPDK and LibRBD and
yeah, exactly, SPDK.
Yeah, so SPDK is on, so that's easy. But LibRBD is going with LibRados. It's too heavy for the. We tried it and it was too slow. Basically, crash. It's very heavy and everything is heavy. At the moment, maybe you'll get better.
Yeah, let's hope. Thank you.
Yeah, I talked to a couple people about yesterday about running Ceph IPv6 only. Are there any plans to add a IPv6 endpoint to the telemetry so I can actually send my telemetry?
Thank you. That's a great question. We had a discussion about it with the video yesterday, And hopefully we'll find a solution. We are in the process of moving our community cage from one lab to another. So we intend to take care of that. So yeah, thank you for being interested in that.
Great, thank you.
Sure.
Yeah. Related to IPv6, one of the issues we have upstream, as far as I know, we don't have dedicated lab for the testing. So far, the feedback we have got from some users recently, it seems that it is working, and it seems like nothing is broken there. So far, we have been fixing issues, but it is really hard, like, to make sure that you are not breaking anything, because whenever you introduce some change, we don't have good automated testing for IPv6 around. We only have automated testing for IPv4. I think it's one thing that we should discuss upstream, and
So
to have more automated testing for that.
yeah, so the good news is that Vido and Stefan has suggested to donate some hardware. So this is excellent. So hopefully we'll be able to do that soon.
Yeah. Excellent news.
Okay, let's go to a question from...
Hi there. So I have a question on Ceph CSI. I was just sort of wondering if you have any plans with dynamic provisioning, any plans to basically allow for the creation of a PV outside of a subvolume group on Cephfs? Or no?
No, I don't think so. No.
Okay, cool. Thanks very much.
Okay. I had a question for the RBD mirroring. Yesterday I was talking, back at CERN, Enrico and I, we've tested quite some, with a previous student as well, the different mirroring techniques with the log-based approach and the snapshot-based approach. But it's been a while since I've touched that. Like, what's the latest advice to make let's say, a very large-scale mirroring BCD, the disaster recovery plan for 50,000 volumes?
I mean, so right now there are two modes of mirroring. Like Dan mentioned, we have the journal-based mirroring and snapshot-based mirroring. And journal-based mirroring was the one that was first developed where you first writes are made to the journal first, and then the writes are actually made to the OSDs where you store the data, and then the secondary copies over the data from the journal. So this not only adds latency, but you also need extra storage for the journal. I think this was something that Josh developed, and I think now we've moved to the snapshot-based mirroring, which is where we take crash-consistent snapshots and then mirror the snapshot delta. This is what the team is currently focusing on, because we don't have the latency issue or the additional storage overhead. And right now we haven't gone up to like 50,000 that you're talking about. The limit that we're now testing is right now, I would say, maybe 100 images at this time. So it's still a long way to go in terms of stabilizing the snapshot-based mirroring feature.
But you can scale out many daemons, right? Yeah. You can have many. So
yeah, the way we want to scale it is to have multiple RBD mirror daemons and make sure the load balancing works between these daemons. Yeah.
Thank you.
Yeah, I have a question on RBD. Is there any plan to support RBD namespace quotas? Because this is something missing, I guess.
I'm not aware of it, but I don't. Yeah. So.
I would like it, but it's not in. The team doesn't have the capacity to look at it. Any idea how to implement? It's very hard also to implement. So no, not at the moment. If you want quotas, you need a pool.
Okay, thank you.
I think it's also worth asking about perhaps why you want the quotas exactly, what use case. Maybe we can talk more later.
Oh, sorry.
Yeah, so the fact is that we started creating pools for each Kubernetes cluster that uses the RBD, let's say, usage. And then we started to grow the count of Kubernetes cluster, but then it's hard to really have a count of PG in the cluster which is appropriate. Therefore, we were suggested to use and to move to RBD namespaces and stick on a single pool. But now we miss the feature of having the quota for that Kubernetes cluster.
Okay, got it, thanks. Yeah, I think that's exactly why you answered as well.
Yeah, that's why I wanted to.
Yeah, thank you.
When will package support be added to Ceph ADM?
Sorry, can you repeat the question?
When will package support be added to Ceph ADM?
New package to be added?
Package support for packages, not just containers.
What do you mean exactly? Because I don't get it.
Ceph ADM supports packages.
Yes.
Ceph Ansible or containers. Ceph Ansible used to support packages. When will we add package support back so people who still would like to deploy packages can use the upstream community orchestration tool?
Yeah, I'm not aware of any plans. If it was dropped, I'm not aware of any plans to get it back, unless like there is a lot of users, community asking for it. Then we can see if the support.
Cool. Thank you.
Yeah, sure.
Yeah, I think there is an idea. Anybody can add this kind of orchestration backend if they wanted to have a different implementation from what Ceph ADM is it's using containers today. It could be using a different form of running things as well. It could be using a unikernel. It could be using anything, right? So I think if anybody's really interested in that, absolutely, it's welcome.
Did you have a question?
I have a question. Yeah, I'm changing the mic just to not create confusion. It's an OSD related question. So every now and then we have like one sick disk across the whole cluster, and then we start to have laggy PGs, slow operations, maybe because of a loosey SATA connector or anything half-baked like this. So the drive is not healthy, but it's not as bad as dead. And this typically turns into operational problem, and it's not immediately easy to identify which is the sick drive because the PGs are shared across multiple drives. So maybe if you get a warning about the PG, you have to go through and check every single drive. It's not so obvious to identify which is the broken one. So I was wondering if there is any plans in the OSD component itself to do some sort of constant probing of the physical device underneath and check if it is performing as it should or not, and maybe raise some warnings accordingly.
I think Igor. So you're asking about the relation between them, right? I mean, if we can tell that the drive is not healthy, then we need to understand exactly what is going to be impacted. We can tell now we can look at the smart metrics or NVMe metrics but we need that missing link. That's what you're saying. I'm pretty sure I saw a tracker from, I think it was Igor, to expose some metrics. Maybe Adam, you know, I think it was like a couple of months ago.
I don't know what kind of information you need, but recently we merged functionality that a specific block device that is going into a slow ops will issue a health warn. But that's just it. If you have overall degradation that affects you, but it does not translate to any specific I/O being outrageously slow, then it will not notice it. So please file a tracker. How do you want to improve on that? Maybe we can squeeze something.
And yeah, just on top of that, what we also did is we kind of added a summary of slow ops in the previous release, I think, Reef. So it's basically like earlier you used to see, okay, there are like tons of slow ops and that you see in the cluster log and, logging, and then it's difficult to figure out whether it's the same OSD or without scripting, right? What we did is we now have a summary. So if there's one problematic OSD having a pattern of slow ops, so that is going to show up like again and again, so that you kind of, again, it needs user action, but it makes it more obvious. So that's the addition at the OSD level, and what Adam mentioned is the Blue Store level. But if both of them are not enough, we are happy to. I think it's a real problem that we should address.
Okay, we'll take one last question, and then we have to finish. Yeah.
Well, from a hardware perspective, both hard drives and NVMEs are getting denser and denser. And from our perspective, 45, people always want to go as dense as they can, especially on the drives. And I know, not a great idea, but do we have any plans on, because hard drive manufacturers, they're just jamming more and more and more capacity into those. What do we think about 24? Like, I'm getting 30 terabyte drives in the new year for testing and stuff like that. Got any plans on how we're going to handle storage media itself just getting denser and denser and denser?
Yeah, the current value is 122 terabytes per NVMe. That's what everyone at supercomputers walking around with in their pocket. So yeah, what do we do, guys? I mean, I had a talk similar to this that didn't get accepted, which was we need to increase the PG number and calculate exactly what is the correct one, but it wasn't accepted. So
I guess that's my answer.
No, I mean, it needs to increase, but you can't make it infinite because of all those weird, like, the smaller the PG number, the more reliable a cluster is. Somehow it's weird, but that also has these other impacts, right? With 122 terabyte devices with 100, that's 1 terabyte of data in each PG. It means you have to backfill 1 terabyte at a time. Good luck, guys.
I'm already getting jitters about M-clock with this.
M-clock? Oh.
Backfill.
Because I'll just add, there is kind of decoupling from that. Like, speaking with Seagate and all these people, like they're going denser, and then they go, why don't you buy denser drives from us? And you're like, well, software-defined storage doesn't like it. And then they're like, what? I hadn't considered that. So
it's like, think about it like this. The time it takes to backfill 1 PG, that's the biggest variable influences the mean time to data loss in a storage cluster, right? Because that's why we fixed RAID. Ceph fixed RAID because you used to have to replicate a whole disk when they were, wow, 1 terabyte disk. It's going to take forever to backfill it, right? So now we've got 1 terabyte PGs. We're there. Yeah.
Yeah, I think there are a lot of solutions that it could be done here. Like you could imagine different ways of partitioning the recovery. You don't have to do it at a sub-PG granularity, perhaps, without having to run into the scalability bottlenecks of increasing the PG number itself. So I think it's definitely worth more discussion.
Yeah. Okay. Yeah, and I think that's the end, right? Yeah, we were only 25 seconds over, so that's the end. Does anyone know where we go now? It's not the end. It's a break.
It's a break.
And then?
It's the same break. Right? Auditorium A.
Auditorium A.
Reconvene, I think, 10.
So it's
50.
a break in Auditorium A over to the other.